Okay, so we'll talk about reward matrix and dominated actions. And reward matrices are important because they help us in making a decision under uncertainty. So if you want to use a decision rule, you must have a reward matrix to go by. And here's an example where I have 4 actions and 4 states, and I'm going to assume that the model has only 4 actions and 4 states. There are no other actions that I'm missing, there are no other states that I'm missing, and I've filled it with a bunch of values, and each value is called a reward. So these reward values are generally obtained from a reward function. In most cases, the reward function is simple, but sometimes it could be a complicated function. And in the simplest case, it would just be a piecewise function involving pieces of constant functions, but in other complicated cases, it would actually involve probability densities and probabilities. So what we have here is a reward matrix with 16 possible rewards. So I can denote Rij as the reward in ith row and jth column. Now I'd like to know a dominating action. So if that is a dominating action, so it is not always true that we will have a dominating action, but if at all possible, it's best to know the dominating action. So an action let's say AM dominates action AN if the rewards that I have in MI are greater than or equal to the rewards that I have for action N. And also, this is for all possible states, I equals 1, 2, 3, ... In our case, there are only 4. And also, there exists at least one K such that R MK is strictly greater than R NK. So, in other words, you have to have all rewards greater than the previous action or the action that you're comparing to, and at the same time there has to be at least one action which is strictly greater than the rest. So let's go back to our matrix and let's observe A1 and A2. If you compare A1 and A2, the reward in for the first state over here is strictly greater than what the reward we have for action 1. 150 is greater than 100. In the next column, you can say that 150 is greater than 70. So that particular state is dominating. The next case is 150 greater than 100, definitely greater. And 150 is greater than 90 for the 4th column also. So from the looks of it, we can conclude that A2 dominates A1. And we can also see, if you use the same logic, you can see that A3 would also dominate A1, and likewise A4 dominates A1. So A1 is actually dominated by all the other actions. So our first deduction is A2, A3, and A4 dominate A1. I could actually write it as a notation, A2, A3, A4. This is not a standard notation, but I'll just use this notation for this lecture. So A2, A3, A4 dominates A1. Now I go back to the matrix again. Now that I know that A1 is being dominated by all the other actions. Now we have to say, or we have to look for the unique dominating action if that is 1. So I proceed with the same process, but this time I compare A2, A3 and A4. So does A3 dominate A2? Technically speaking, A3 does not dominate A2, because although the first, the second, and the third column have roots that are identical, if you observe column number 3, A2 has 150 and A3 has 110. So clearly A2 dominates A3. So that is our second deduction. A2 dominates A3. That's nice, but what about A4? Does A2 dominate A4? But if you observe carefully, A2 does not dominate A4. A2 dominates A3, but A2 does not dominate A4, because here A2 has 150 for state 4, but A4 has a reward of 200. So A2 does not dominate A4. But does A4 dominate A2? Of course A4 dominates A2, because you have 150s in columns 1, 2 and 3, and column 4 you have 200, which is definitely greater than 150. So I can conclude that A4 dominates A2. So I can rewrite this as A4 dominates A2, which actually dominates A3. Well, using transitivity, if A2 dominates A3 and if A4 dominates A2, it is obvious that A4 dominates A2. But then we know A2, A3 and A4 dominate A1, so we can have the following structure. So we'd actually have A4 dominating A2, which would dominate A3, but collectively the very first steps that I did is A2, A3 and A4 dominate A1, so they all dominate A1. So the dominating action is A4. You don't have to pursue this process in finding a dominating action given a state-space model. All we have to do is to observe a matrix and come to a conclusion and identify if that is a dominating action. Some students can just look at the matrix and immediately come to a conclusion that the dominating action is A4. Some really like to go through the process writing, what dominates what else, and eventually at the end of the process you identify the dominating action. So dominating actions do play a significant role in decision rules. People would want to know dominating actions, but the rules directly or indirectly take into account of the dominating action in coming up with a decision. So I hope you understood the concept of a ruled matrix and dominated actions from this video, and in the next video I'll probably move on to decision rules.